Well, hi, good morning. Thank you so much for joining me here in my shop for a little more fun with this radio. What I'm hoping to do is do an alignment on this radio, do a kind of a quick job if you like, just to make sure there isn't an alignment issue. I mean, the radio works quite well, so I'd be stunned if there was. But just in looking at it here this morning, just when I was getting ready, just before flipping on the cameras, I noticed a couple things in here right away that I think are worth talking about. So this particular radio has a B- bus wire running right through the middle of it. I mean, it's a great big guy. I've seen this on quite a few radios. This is not commonly done, let's put it that way, but you're going to encounter this. This adds a certain layout to this radio that makes things really easy to spot. For instance, can you spot the capacitors that are connected to ground or to the B-? Oh my gosh, yes. That one, that one, that one. Those big ones I put in. This one. Try to do that with another radio. Try to just spot capacitors that are tied to ground or the negative bus. Not that easy, that's for sure. Then you flip that over. What about capacitors that are not connected to ground or to the B- bus? We can spot those really quick too. Here's one here. Here's one here. And there's some other, I'm just pointing at the wax ones, and there's some non-wax ones in here I'm not too concerned about. So that's a little bit interesting right there. It just visually, you can very rapidly separate the capacitors in this radio. Now most of the ones that go to ground are busily trying to drain something back to the B-, usually trying to drain out RF or something of that sort. And the ones that aren't connected to the B- are probably conducting the signal from something to something. Oh, that's kind of interesting in a way. Right there. And one more thing I've noticed. I did replace the capacitor over here because I saw it was tied between the chassis and this B- line. So I thought, oh, I'll change that one. Why not? It's a bit of a safety sort of thing. Well, there's another one in here that I've now noticed. It's sticking right out, and that's this one. So this one is connected to the B- here, and the other end of it is onto the switch terminal at the back of the volume control, the on-off switch. I just quickly cast my eyes to make sure the power's off on this guy. So, and it is. So I think this one's worth changing just from a safety point of view. It'd be another chance to test one of these capacitors and see its condition and help me decide what to do about the rest of them. Which we're only down to 1, 2, 3, 4, 5, 6 more wax ones. So we're slowly changing them all anyway. So I think I'm going to do this one before I do the alignment, just to get this guy out of here. We'll take a peek on the schematic here. So which capacitor is it I just pointed to? It's this guy right here. And he's right across the power plug. I missed him. I should have spotted it here on the schematic when I was doing the review, but I didn't. I missed it. So I'm going to change this one out, 0.025. Great. I'll get that done, and then we'll carry on with the alignment. So 24 hours has gone by since the last moments on the video, and here I am again trying to carry on with the alignment process, and I'm just trying to decide where to connect the scope, or the voltmeter rather, the voltmeter I want to read the AVC voltage with. So a very easy target on almost all these radios is just to go on the input side of the volume control. That's a pretty simple thing. So you just take a look at the volume control here. It's not long before you'll see that one of these terminals is tied to ground, chassis, or B-. This black wire goes right to the B- conductor here. So this would be the live, or the input side. And you can see a wire coming back, and it comes back to this coil. From the coil, I can see a red, green, which is 2.2 megohm resistor, which appears on the schematic. But there is something definitely missing here. There's another resistor missing. that's on the schematic. And so I've been looking at this, waiting to start the video, trying to sort it out. I haven't been able to sort it out, so I thought, well, let's put it all on video here and just see if that helps me or not. So what we really want to look at is the detector tube. Maybe that's my problem right there. Detector tube, 2 plates, I can see them shorted together. Wire coming over to this terminal. I wonder if the resistor I'm looking for is internal. It's inside this can. I'll bet you it is. Okay, so we're coming over, and it looks like these terminals are numbered, but of course the numbers are blocked. I can only see part of the numbering. I don't know what that could be. Could be 3, could be 6. Okay, let's see what it does. It comes from the tube right to here and disappears inside. So I was wrong in what I was seeing. Of course I'm wrong. So what I'm saying here is on the detector, this resistor here, 47K, is inside the can. And this terminal is actually the terminal produced at the top of the can. So that's why I can't see the 47K resistor. Now that would make sense because, 1, 2, 3, 4, 5, but there's 6 terminals. 6. So on this terminal I would find a 2.2, it's sitting right there. I find a 100 picofarad, it's right there. Oops, yeah. So that's what's going on. So I can't find this because it's buried inside. So where I'm going to connect then is here. I'm going to connect at this point, which is kind of between a hidden 50,000 ohm resistor, a 1 megohm variable resistor here. So the bulk of the output of this diode is going to be sitting across this volume control. So that's a good place to read it, of course. And rather not get on the other side of this 2.2 because it'll probably interfere with the radio a bit. So that's the spot as usual. Okay, no big deal. The big deal was this resistor's hidden from view and I spent too much time trying to find it. While we're on here, let's just bop down to the instructions. Tune the set to the extreme low frequency position. Capacitor plates closed. Okay, I'm going to do that. That's done. Okay. Connect ground terminal, introduce a modulated. I've done all this. I got all this ready. Now we got to do this. We got to do this in. They want to do it in this order. IF aligners, starting with secondary of the second. So this shows me which ones to do. Secondary of the second right here. Good. Okay, we're set. We are set. Now I've already got the signal generator running. The signal generator input. Oh, this is another aspect of this. We're going right. I think I talked about this earlier. I'll leave it off right now. So we're going right in on the local oscillator grid. To grounds. Voltmeter. Okay, yeah, I gotta hook up the voltmeter after talking about it all that time. I better hook it up. So we're gonna go on the high terminal. We want it to go on the, yeah, I can get it here. I think this is probably a better place to get it. Okay. Now the deal with this radio is everything has to be done from the top. So I'm going to have to flip the radio over. So I'm going to put this forward like this. This guy can stay like that. Flip it over. Everything stay in place. That's the theory. Let's see what happens. Okay, what happens is you really don't know what happens. Good leads are buried. Okay, this can still go on there. Good. paint knocked off? Yes, even more paint coming off. Oh my gosh, what am I going to do about that? So I think we're all set here without any trouble. Signal output is set low. We're set on the voltmeter here for 50 volts. Negative is upscale. Yeah, we're ready. Here we go. Are you ready? Apparently yes. Apparently yes. A little volume. Okay, something is not right here. Something has not gone right. There's no sound at all. What happened? Okay, so voltmeter is hooked up. Nothing on the voltmeter. What is going on here? Nothing on the voltmeter. No sound. Oh, maybe the capacitor shorted. That's full volume. What has happened? What's with this volume control? Feels like it's... Oh my gosh. What happened there? Is that my imagination, or did this come bright? So I wasn't looking right at the light. Son of a gun, what was that? Bad clip lead. Bad clip lead. Let's check. Power off. Bad clip lead. Bad clip lead. Clip leads have a way of going where they want after you hook them up. Or, you know what? That looks okay, doesn't it? I'm going to move that clip lead. Switch is off. Oh, I'm holding on to the chassis. See, this is a danger right here. Holding on to the chassis. Fooling around. Let's keep fooling around. I've shut the power off here. We'll pick this off in a slightly less convenient spot. Okay, hang on here. So electrically it's exactly the same. Come on. Put that on. I can see how it's going to reach right to the chassis and ground it. There we are. That's good. That's going to do it. Maybe I should leave this set sideways. Let's leave it sideways. That's probably a better idea. Well, I can't really leave it sideways. Let's leave it the other sideways. Let's leave it the other sideways. Okay. Oh, it's still tippy, isn't it? Oh yeah, it's tippy. Tippy, tippy, tippy. Tippy, tippy, tippy. There we go. Okay, no longer tippy. This guy is... I want this guy clipped onto the oscillator. that hanging in there, that's for sure. Okay, I think we're ready again. Volume down. Wow, that's just really, really grindy. Where's my magic elixir? Okay, anti-WD 40 people, look away, look away. Oh my gosh, I'm gonna get in there. That volume control is really sealed. Well, we're gonna try. So it could be the shaft binding up here a little bit. The crazy thing about this is when you have the nozzle in the button and you push the button, you move the nozzle tip. It's like having a, well, that made a big difference right there. That made a big difference. It's like having a gun where when you squeeze the trigger, the gun re-aims every time. I'm going to put a little in here too. Why not? Share the goodness. Now, this guy, I already did this guy. Feels good. That feels a little better. Just about put my finger through the speaker. Okay, switch is on, power coming, plug, power everybody, stand back, here we go. A little volume, oh that's totally different, totally different. Don't know if I got any in on the contacts though. Started wondering if it was working. That's nice. That's nice now. That's very nice. Okay, we're ready to finally do the alignment. Okay, let's first set the frequency generator here. Whoops. Just about guillotined my hand there. My camera tripod has guillotined my hand a few times. Okay. 459, which is 460 is what we're aiming for on this radio. And by the way, the voltage has magically appeared. Let me tune the radio a little bit here. We'll just, yeah, good. Okay, we got some AVC action there. Excellent. Now the signal input from here, low level to here. Okay, so that just silenced the radio. Now, why would that be? There's no longer a strong signal of any sort, including noise, presented to the front end of the IF. That would be because, can't quite explain that. Having silenced the local oscillator, you'd still have noise and stuff coming from the antenna. I just turn it up. Nope, that's not okay. Won't worry about why it's doing what it's doing, but in any case, it's doing enough. Still at 459. Why don't I hear it? Signal level too low on the signal generator. Let me snap it up a bit. There it is. There it is. Now, in terms of getting a reading on the meter over here, extremely low right now. So that's 15 volt scale. I'm going to stop, rearrange cameras, and continue on at this point. Okay, let's go. Now, we're going to check with a metal screwdriver here as usual, as soon as I can find one. Second, first, secondary, primary, secondary, primary. Starting in the secondary of the second. Okay, now watching that meter, what's it going to do? Okay, so these coils inside these cans are really super highly engineered and designed things. I don't talk about them very much, but really, to some degree, the radio is a set of coils. And everything else is just kind of optimizing the coils. It's not quite true, but I'll kind of think of it that way. Okay, we're getting a little bit. I wouldn't say too much to write home about yet. You know, this is too small a screwdriver. It's too small. Give me something with a little more. I wonder if I can do it with this. I think so. And the shaft is too long. No, okay, it came loose. So apparently the first transformer has a fair bit of control over the bandwidth. I've been reading up on bandwidth because I'm using the sweeper. I can see the shape and all this kind of stuff. Let's go through them again. So I've been reading up on this. Okay, we're still at 460 on the signal generator. So there is the possibility of doing this too good, getting things too sharp. Now why did I kind of bop there? Hey, this screw's not been turned yet. I think I skipped this one. Let me get that. Let me get an even another. Let me get an even another screwdriver. I like this one better. Okay, so I missed this screw. There it goes. Oh, no, what's with it? What's going on here? There. Oh, it's just really sticky. Oh, this guy's got something. Or did I just knock it off? It's easy to get fooled while you're doing this into thinking you're boosting things when you're really just kind of moving around a little bit. Like, if this was tuned to 455 and now I'm tuning it to 460, while I'm doing this, it looks like I'm boosting it, but in fact, I'm just moving it. So this isn't a big change. Not like the last radio I did was a mile out. Somebody had done these by ear or something and not done a very good job of it. Okay, well that wasn't a great amount of improvement. Now, there is another adjustment in here. There's a 460 trap. That's designed to stop the local oscillator from working its way out the antenna, bothering the neighbors. So we're going to feed the 460 into the antenna, and from there adjust this one, and the adjustment's right in here. Okay, so let me just turn this down, move to the antenna. Okay, we don't hear it at all. Up, there it is. Now I just make it as weak as possible. That's the objective here. Okay. See in there. I'm sticking a metal screwdriver deep through the chassis. I don't like that idea. Let's see if we can get this one. The shaft was going to ground out on the chassis. Okay, we're in. So anything at 460 that gets to the antenna gets knocked to ground through that filter there. So, okay, there we go. So from here it's the RF alignment, and I'm guessing there's only 2 stages to it. And I'm noticing already that the capacitor here, let's see if I can get it. Okay, so it's a little hard to appreciate on camera, but this screw is backed out almost all the way. There. Can't go much further. So this is RF, this is oscillator. Let's see what the instructions say here. What do the instructions say? Okay, just peeking at them on my own. Replace the 0.01 capacitor in series with the output lead with a 200 picofarad capacitor. Connect them to the antenna terminal located on the back of the loop assembly. So I need a 200 pico for there. Okay, so I'm gonna just get this stuff set up and we'll get going from there. Okay. So the next step, which is adjusting the 2 trimmers on the capacitor, the local oscillator and the front end, are done at 1400. So we're going to tune through the band. Let's hear what we hear. For an antenna, I'm using essentially the signal generator, so don't know what we're going to hear here. Well, this is the antenna. Wow, that doesn't make much difference, does it? Oop. Look at how strong that... Now that's a noise signal in my shop, almost unmodulated. Lots of good AVC action. Okay, 1400, and the signal generator is already there, waiting. Hey, where are you? Surprised I didn't hear that. The signal's fairly high. Okay, let's give it a boot. Find it now. There it is. So, assuming these marks are the center point of each frequency, because the pointer's on a funny angle, of course, coming through here, I've got this right in the center of this little symbol. And it's 14. It's right on the money. What am I here for? Now, we're going to try adjusting the local oscillator to maximize the signal strength on the meter. Let me turn this down a bit here. About as weak as we dare. Okay, so this corrects for the dial pointer, but I've already, this isn't going to do any good. This is not going to do any good. But I've done it anyway. Because it's right on 1400 anyhow. Now this one, I'm hoping something good is going to come of this. Tightening it up. It's going down. Down, 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 down. So here's a radio that's in this condition that I find a lot of these radios are in, where you have to open this capacitor all the way. So, what are you supposed to do in a situation like this? I'm going to close the capacitor. Okay, it's just snug. I'm going to back it up half a turn. Now I'm going to try the local oscillator again. Now it shouldn't make any difference. So this would be the conclusion here. I think I might crank this. I'm up at 1400. There's no station. Don't touch that face, Jim. There's no stations up there. So no stations normally listen to. They're all down in this area. So let's pick one. I don't even need. I really don't need to pick one. Let's go on 600. There's a reason. Oh, 600 would be right here. Assuming again they go to the center of that marker. That'd be 600. That's probably why they put these markers on here, because people wouldn't have any idea where do you tune. This way, a square dial with a round, sweeping pointer. So we'll assume that's 600. Let's find out. Okay, so it's not 600. The 600 is here. Where? There. Look at it. It's lined up right on the point, right on the decimal point. And the pointer is going right through the 60. Now, for sure, if I adjust the local oscillator to match here, it's going to be way out on this end. I don't care so much about that end. But if I were tuning this radio and I really hadn't paid much attention, I wouldn't have spotted these dots. I think from here, so we're not really talking. Oh! Let me do that RF guy again. No, just open is higher. The screw's practically falling out. So the bottom or the top, it doesn't matter. That capacitance has to be opened all the way. What do you do about that? So we're not resonating something properly. Well, I think it might have to do with the antenna. And it's just possible that the inductance of this antenna is not what it used to be. It's a little off, and so the capacitor that's matching it here is no longer sufficient. The little trimmer is no longer sufficient. Not sure about any of that. I think a good idea would be to switch now and take a look at the results we've got here using different techniques, using better, more advanced techniques. This is where you're going to get to with this method, simple method. Or did I overlook something in the instructions? Let me just take a quick look, just to make sure. It says set the signal generator's frequency and receivers to 600. That's exactly what we did, actually. Then it says, note, if the calibration is too far off at 600 megacycles, 600 kilocycles, repeat 2 and 3 until the best results are obtained. So they're almost admitting that you may not be able to get this thing to work 100% everywhere. But I don't like that open capacitor, and this is a problem I run into all the time. See, I could just boost the trimmer capacitor and add more capacitance into it. But basically, I'm adding more capacitance to the whole tuning capacitor at that point. We've never done anything like that. Let's look at it on some other instrumentation and see what we really got going here. Okay, so you see the SDR frequency spectrum display in the top right corner, of course. Bright yellow line on the waterfall part of the display. And how have I done this? You can't quite see from that angle. Just move it like this. I've taken a oscilloscope test probe and abused it by plugging it into the antenna input on my SDR, which is just here. That's my SDR just sitting up here. And all I've done is taken the probe without even the metal hook part that sticks out the end when you squeeze it. I've left that retracted and I've just shoved it into the oscillator coil top. Just shoved it in there. So there's no electrical contact, but that's more than enough, I have discovered, to produce the where am I going? Help, lost. I'm lost in the shop. That's more than enough. So let's examine this SDR situation. I'm going to put it, well, we can do it right here. So what frequency is that? Oh! Yeah. I'm going to throw this cord up. Kind of interesting. Not sure where the noise is coming from. Now stay in there, would you? No, you won't. Well, I'll make you. I'll make you. Oh my gosh. Where's that noise? Is that camera noise coming through? There's noise on this radio. Okay, I will. Here, I can fix that. Okay, good. Now let's get back to measuring what is the frequency, Kenneth. The frequency is 1058. Now normally this would be, it's 10, let's see, it's 460. So 460 should give us 1060. So we should have 1060 here. I put this on to 1060. What's it look like? Looks like it's a hair off. Let's zoom in. Zooming in. Zooming in a little further. A little further. So there's the signal. Now, maybe so I'm looking over here. Aha! No, order, shift. So you usually got to have this set to, I think, -40. That didn't do anything. So we have to verify, again, the calibration of my SDR. So the way we're going to do that, try to pick up an actual radio station here at 640. What about 1010? Any chance of hearing that? There is a station at 1010. We'll turn on the speakers here. Okay. Can we get 1010? Come out. Wow, nothing. Hey, what's gone wrong here? Well, what am I holding on to? Somebody's not happy. Somebody's not happy here. I have to troubleshoot the troubleshooting equipment. Aha. Is this not making contact? I didn't put it on hard enough? Okay, we solved that one. Next. Yeah, we're going to try to pick up, well, I was going to try 1010 here. I'm not going to get 1010, but I bet you I can get 640 here. Let's go 640. How about 590? Let's go 590. 590. You can see a little thing there. What do we get when we touch it? There we are. Now we want to max this out. Okay, just I have to be the antenna just now. Just sit here, will you? Good. Okay, I'm going to expand this out. Now I'm going to stick my finger on the trigger. So you can see we're dead on 590. So this verifies the calibration of the SDR. Stick this back into the local oscillator coil. Go back and find the local oscillator, which is way up here somewhere. Let me unshrink. There it is here. Okay, expand it. Now, frequency measurement here is actually $157. We really want this to be 1060. What would that look like? So this is really where the local oscillator should be, to be tuned at 460. So what we'll do, we'll change the local oscillator frequency just by tuning the radio and get them lined up. So I'm tuning the radio to 600. Well, that's crazy close. That's good. So radio is tuned to 600 kilohertz. Exactly. So if I've done the IF properly, we should hear that 600. There's a 600 hertz signal, 600 kilohertz signal coming out of here. And where's it going? It's going still on the antenna. Okay, turn it up. There it is. So this is just a touch high. So I got some argument between signal generators here. So I would say the radio is tuned to 605. On the dial, it's nowhere near. So what do? We go with the marks? Well, why else would they put those marks there? You can see how the marks are, following the variation in the, we got to follow the mark. Right. Wow, this is a dumb situation. I think most people would tend to do exactly what I just did there. But I'm not most people, and this is my radio. So we're going to go here. So now we should be able to hear that signal generator, and we can't. So we're going to move this till we hear it. Can't hear it. Really? We can't get there from here? Okay, we'll just turn it a little bit. Sure, we can get there. Is my SDR doing funny things there while I do this? Yes, it is the SDR doing that. I can't get there. So I've got the capacitor open now. It won't go there. So from a very, very practical point of view, when you're tuning a radio like this, the last stage of tuning is always what you're hearing. So you use the dial to get the pointer close. Hopefully pick the right station if they're close together. 590, 640, 680. Pretty easy to pick off which is which here, I think, even with it tuned like this. So, you know, in terms of just from a very practical point of view, it's probably good enough, right? Probably good enough. Particularly, why is it these radios just go out of range? It can no longer be brought back into range. Okay, let's settle with that. So 600. What I'm going to do, I'm going to put it right in the middle of the 600. This is dumb. I'm going to tune it there. Okay, now we can watch that. Watch the meter. Then I'm going to line up the front end to here. Just open all the way. Let's introduce the sweep on this. Okay, let's see if I can get all this stuff to work now. So we're still listening to the single frequency. I'll switch to the sweep frequency. The sweep is sweeping from 510, 90 below, to 690, 90 above. So 600 should be in the center of the scope once we let it sweep. So this should be 600. I think I'm doing this right. Okay, so we're going to move the signal generator. So this is just basically on the antenna here. Look out, man! Okay. That was almost a big bang there. There we go. Input's very low. Let's crank it up. SDR is still looking at the local oscillator and whatever else might show up. Here we go. Okay, a little more juice here. I have nothing on the scope because I haven't hooked the scope up to anything. That's kind of dumb. That's not going to work. Okay, there's the scope lead here. And we want to hook this guy up to where? To the same place that the meter was connected. The white clip lead is way down there. I think I can do this on the end of the white clip lead. Let's try it. So go on the negative bus. And scope lead onto here. Okay, everybody hold still. Now we're getting a nice display here. Very good. Now, let's think about where we're at here. Okay. Enough thinking. What's all this proving here? So this has not shown up on the center line, but I'm a little off center on the display. Okay, so now the start and stop frequency of the sweep tends to drift. Let's take a look at it. Start is 508. We'll make it even closer to 510. Okay, that's really close. The stop, 90 above 600. We'll just make that a little closer to 690. There we go. Okay, sweep now. We'll make sure the sweep is centered. It's not quite centered here. Yeah, this is questionable in terms of, you know, precision, but so 600 should be this center line here, and you can see the tuning is off 600. So tune the radio. Hey, what was that? Well, what is picking it up? Hey, what's going on over there? What was all that? What's going on there? Okay, so I have no explanation for what I'm seeing here. So four separate peaks. 4 separate peaks. How do you end up with that? What does that mean? Let's switch back to the single frequency. I'm just going to tune through with the single frequency. Now wait a minute, think about this. It's picking it up at different places. It's picking it up at different places. Maybe those are noise signals. No, that can't be. How come you can't hear it here? That's the real question, isn't it? Because I'm out of the range of the sweep. That's what's going on. I'm passing out of the range. So this is the start of the sweep. Don't know what that is. Looks like the real thing. And don't know what that is, and we can't get off the other end of the sweep. What the heck? That didn't help. Going off the end of the sweep makes sense. You don't hear it now. You hear that. Okay, I'm totally beside myself. I really am. Yeah. I continue to be out. I'm going to broaden out the sweep on the sweep generator. way out. So, and see, we're going to start it at, well, we'll start it just below, well, it actually is already below the AM band. Let's put it right at 500, because that's a nice number. I like that number. 500. Okay, and then we'll put the upper one at the top end of the band, 1600 plus a little. 1600. Don't go so fast. We can't get, yeah, 1 meg, we can't get up there. Gotta do this, gotta do the whole thing over again. Back to the start. Start frequency. Right around, well, how about that, 540. It's not quite the bottom. Let's see if we can get it this way. 500. A bit of a hair trigger. Okay, that's good enough. 515, that'll do it. Stop frequency. It's going to be 16. We'll go a little above. 16125. Okay, sweet. You hear it? You see something on the screen? Wandering around a little bit. Okay, let's tune the radio and see what happens. You know, this thing's just receiving so much stuff in here, like, you know, that other thing might have been a noise signal. Because the way we're sending this signal in is through the screw on the back, the antenna screw. That means this whole coil is still completely active on the radio. So it's busily receiving stuff while I'm doing this. Why would I not try to knock out the antenna by using the low impedance of the signal generator? There's a capacitor back here right now. Directional antenna. If I bypass the capacitor and go straight on. Oh. What is going on now? Okay, so I disconnected the sweep generator. Is he just putting out a huge, look at it. I disconnected it from the antenna here. Doesn't make any difference. Something very, very, very bad going on here. Okay, a very sensitive antenna. Radio. Antenna right here. A little bit of... It's like there's no... So I stop the sweep and the sound goes away. Is it just because I got the negative hooked up onto the B minus? That shouldn't really bring the radio to so much life. Well, I don't have to hook this wire up to anything. Just have it nearby. Sweep on again. Ground this right out. Still going. So I've clipped the, it's hard to see here. I've now got the output of the signal. Oh, maybe it's laying right on the coil. That's probably what's going on. Okay. So, lousy. Let's get it away from the antenna. flying conductor. Too many things at once. Back in. And I want to put this onto that antenna. I got to swing it around. Sweep is running. More power. It's all kind of a mystery to me just what the heck's going on here. Put a little more brightness on the scope. If this is jumping around, that's not going to help me any. Tune. It's still picking up all kinds of stuff. See, so I'm guessing now it's picking up a noise signal. The AVC has turned the radio down. The input signal from the sweeper is actually quite low, and the result is we just hear this noise. So to really make this work, I got to kill the antenna somehow. I don't think I know how. Okay, hear that sound? So this is one of the few times I put my other computer in the house on standby. It's on the other side of my house. It's as far away from here as you can get in my house. Hear that? That is my other computer sleeping. So if you went in my studio, the computer appears to be off because it's in sleep mode. Apparently what this is the power supply maintaining voltage to the memory in the computer. You can hear this on the street in front of my house. That's how powerful it is. That computer is just blasting this out. Some really, really strong signals coming out of that computer like that. But I'm not find them now. That's why I don't sleep that computer normally. Okay, we're just fooling around here. Stop fooling around, get busy. So we want to connect this, right onto the capacitor, right onto the antenna capacitor. Should we stick a capacitor on the capacitor in there? I'm hoping this will quiet the radio at the same time it ejects the signal. That's a lot better. Down. Excellent. More sensitive. Excellent. Now we're cooking. So, of course, the instructions that come with the radio for alignment are thinking about people using a single, not doing the sweep thing. So that's maybe why following those instructions isn't going to work with a sweep. Now we tune the radio. Excellent. Excellent. Okay, no funny business anymore. All look. Oh! What's that funny business over there on the right? What was that? What was that? It's hidden out here. Let's bring it in. What are you doing out here? What is that? That could be the sweep end. Let me move the sweeper settings, and we'll see if this doesn't literally go away. There's really something there. So I've shortened the sweep. It's no longer reaching this resonant thing. Whatever it is. Interestingly enough, I can mark this frequency right here. That frequency right there is 1464. Is there a chance that's where the radio's tuned? No, the radio's tuned at the other end. 55 right now. But if we tune the radio, that thing moves? I don't know. To make it very strange. Okay, let's go back to the business end. What did I do? Did I just move this? I didn't just... Yeah, I did. So we want to calibrate the scope now so that this means something. So I'm going to go back to sweeping just through the 600 and go 500 to 700, right around 600. 500 to 700. Okay, 500. 500. Really tricky to set it that accurately. There we are, 500. Excellent. 500 to 700. $500 to 700. So it's sweeping right through that range now. 700. Yeah, and the radio's not tuned. The radio's tuned to... So 600 should be right in the middle here now. So I'm going to tune the radio. Jumping around a bit. Somebody's not steady. It's probably the signal generator. Okay, so I'm pretty sure that's 600. And what do you see on the dial? Okay, so what am I trying to do here now? We're looking at the wave shape, and we're looking at its position. Is it exactly right? And at the same time, we can double check the local oscillator. Hey, what's happened on the local oscillator? So the local oscillator appears to be running at 1050 now, not 1060. Oh, you remember now, the pointer wasn't exactly correct on this radio. Not exactly correct. Is this what I'm kind of fiddling around with now? So the idea is, it should be perfectly straight. Wow, it's really close. I mean, really, can you... Oh, what are you looking at? There. Can you really complain about that? And you know, like, this capacitor doesn't close all the way, does it? Yes, I guess that was the other radio. I can't remember anymore. I had too many radios in my life. Go back just a minute. Hear this tone go up and down. Interesting. It only goes one way. It doesn't go woo, it just goes woo. A little birdie in there. Wait a minute. Oh, for crying out loud. You know what I'm hearing? Oh. Okay, listening to the SDR. Too many radios. There's too many radios in my life. So going back to check the 600 thing again. And the local oscillator is close. And if I put it right on... I'm looking at the SDR now. Right on 1060. This should be 600. Look where it is. On the scope. I think I'm beating around the bush here. I think I'm just going around in circles. I'm not sure there's anything more to get. Let's fiddle with that capacitor trimmer that's wide open again and watch what happens. Don't see anything on the scope happening at all. You know, the way I've done this, because the way I'm feeding the signal in, I'm probably past that. That's why it's not reacting. Well, let's listen to this radio and see what it's doing at this point, other than making that buzzing sound. Okay, all equipment out. Careful now. Everybody off. What about, we'll just leave the AVC meter going there. Take the scope off. So all that's left now is the AVC meter. Why don't we take that off too? There we go. And take the ground off. So now the radio is all by its lonesome here. It's up to you, radio. It's all up to you.
I think that's when we went on our like 18 century, which we almost got our coach fired, and then we'll scored, I think, against Carolina to break that losing streak.
Pretty good null, eh? Look at that, null that station right out. That gives me the perpendicular angle. That's maximum now.
And then he'd go on the ice and he'd look tired because...
Okay, good radio can pick up one station down here. Below 590. Didn't hear it. Let's go up to 610 is a tough one. There it is. 640.
Podium in the nation, and he can in psychological terms, when a leader is paranoid,
I think that's 640.
Or delusional, they actually have much greater emotional force in galvanizing a fervent, irrational following than any rational strategist can have. And so this is a very dangerous situation. And what we would normally do in such a case, apart from the president, anyone else would be contained and managed appropriately. Do not expose such a person to such great powers or weapons or the ability or an audience in a way that they can sway a huge audience. But instead, we've actually done the opposite. We've stripped away any constraints, allowed him to continually swell his own power, and also allowed him unfettered access to the public through Twitter and other means, through rallies, and all this is very dangerous, and we're in perhaps the most dangerous situation possible, in that we have allowed all this unconstrained expansion of power to happen, and then finally at a very late stage we're going ahead with impeachment, and so the shock to the president's system would be the greatest possible, and he still retains all his powers. And
you would like to see him removed from office. You'd like to see him just submit to a mental health examination or removed from office. Is that correct?
That would be the normal course since a long time ago. If he were not president, if he were any other citizen, he would have been contained and evaluated long ago. But because he is president, and even though there's no exemption for a president in mental health laws, we have somehow allowed this very exceptional situation. And so I, exactly what happens is not my domain, because that starts going into the political area, but the normal course of medical management would be to immediately remove the dangers.
What do you say to people? Because I'm getting a lot of email, and I'm getting a lot of hate mail, and I knew I would get this. But from people that say, you know what, this is Trump derangement syndrome, and some people even saying, well, why do you have a psychoanalyst on this? It's affecting credibility. Someone also said, that this is just people are calling him mentally ill because he's a meanie.
No. Actually, I think the squelching of discussion about mental health issues, which are actually very common in the general population, has increased stigma and misconceptions and misunderstandings. Mental illness has nothing to do with criminal behavior or criminal mindedness. The two are actually, in fact, entirely distinct. And to conflate the two, and just because the mental health professional speaks about someone, it doesn't mean we're speaking about mental illness. We are speaking about mental impairment, and his mentoring capacity is very concerning. We did assess his mental incapacity based on, very credible co-worker reports under sworn testimony. That was the Mueller report. And we found him wanting in every criterion. In fact, he failed every criterion of having the mental capacity for rational decision-making, and that should really alarm everyone. So we have someone who does not have rational capacity in the highest office of the land. And, well, it's an unpleasant situation, but how can we, you can't blame the mental health professionals for correctly pointing out the actual situation. And
do you see this letter as further evidence that there's a problem here as far as mental health goes?
Yes, because there, of course, I speak in the op-ed about the phenomenon of shared psychosis. Shared psychosis happens when someone is actually severely impaired, in fact, mentally ill, on top of their criminal mindedness and bad behavior. They become even more dangerous because because of the impairment playing into their bad decisions and guilty ways, so in that case, when someone is severely impaired, the chances of it spreading, in fact, like a contagious disease among those who are in close contact, exponentially increases. And unlike a physical infection, which needs physical contact, this kind of contagion spreads through the airways, through tweets. And so
it's a little harder to control. And Dr. Brandy Lee, I have to unfortunately wrap it up because that's all the time I have in this segment. But I want to thank you for your time.
I just wanted to say I take all responsibility for any of my statements in case of all the hate mail you get.
Well, that's a very kind thing to do. Thank you so much for that.
I stand by my views. Thank you.
I appreciate your time. It's a pleasure to have you on the program. All right, so there you go. Right.
So there you go. Once again, this is Canadian radio, by the way, and that's an American psychologist being interviewed on Canadian radio. If you're American, if you listen to Canadian news, any station, anything here in Canada, you'll hear the same stuff you hear on ABC, NBC, CBS, and all the journalistic outlets. So, I just feel so sorry for what has happened in the United States. It's no joke what is happening. It is being destroyed right in front of our eyes by a mentally ill leader. I mean, there's just no two ways about it. America, you got warned by 500 psychologists a year ago or whatever it was, warning you that there's a danger here. Do you think it's all a big joke? Yeah. Okay, so I gotta stop now because I've lost my mind completely, and I just lost my mind completely. Completely. That's the end of it. That's the end of the video today.